Welcome to CodeTrack. We previously held a couple of events called Track Unit 4, and it's a bit of the same thing. We just wanted a name that didn't sound like a Track Unit and Trifork had a baby. So we came up with CodeTracks instead. We, as Megan mentioned, we have a rather tight deadline. We're going to dive in straight away. A ton of super interesting talks lined up. I'm looking forward to hearing all of them. If you need anything to drink or snacks or coffee or hot chocolate, please go and grab some. I think we don't have a break for it, but when people are switching laptops, it's a good time to go grab some snacks. Let's dive in. I'm first. My name is Mads Tandrup. I work at Track Unit, and I spend a lot of time doing Node.js development and general network optimizations. Today I'm talking about content delivery network and also a twist with how we host APIs. But first, what is this content delivery network? Before we dive into that, let's start out with a concept called reverse proxies. So the idea with a reverse proxy is that you put this server in front of your real server, and then when a request comes in, the client says get/food.html. The proxy just forwards it to the origin. The origin returns a cache control header that says this is public, it has a max age and some other parameters. Then the proxy will store this response in its own data store and return it to the client. Because then the next time somebody says get food, the reverse proxy can look up it from local storage and just return it immediately. That's, of course, that alleviates the origin for some work. But if you take these reverse proxies and scatter them around the globe, you get the benefit of somebody in South America. He doesn't have to talk to a server in the NAM to download a large vendor JS bundle or whatever other large files there are. He can just talk to the local CDN server and get the files faster and quicker. For us in Europe and NAM, it's not that big a deal. If you are in Australia, it's a big deal because their network connectivity is really slow. When you see stats, at a previous job, we had some stats on how fast our site loaded from different parts of the world. And we were hosting in NAM back then, but Australia was by far the slowest one. And it was orders of magnitude slower than what we were getting in Europe. This is important. I have several CDN providers. I've used Cloudflare and again previously in a previous job. Here at Track Unit, we use Amazon CloudFront. They all skip the same functionality. Some provide extra features. Cloudflare, they tend to bundle up a lot of stuff in their offer, whereas Amazon, for example, is more like Lego blocks. You get the CDN, the raw CDN, and then if you want the web application firewall, it's another product that you together with it. You get everything in one package. Some of the benefits, already touched about it. If you're serving files closer to your client, it's much quicker for them, especially if they have a crappy internet provider. They might have a bad cell connection, whatever. When the server is close to a client, it gets the data there quicker. It also gives you less outgoing traffic from the origin because you don't have to repeatedly send the same file to Australia every time somebody in Australia wants to load your site. It gives less load on your origin as well. So that is, if you are doing a single page application, that's maybe not the biggest problem. Then you're just serving up static files. But if you're doing like a news site with lots of visitors and dynamic content, then it can give some benefits. And it also has the potential to protect against distributed denial of service attacks. I've remember Cloudflare, they said that they mitigated one that earlier this year. And that when you search for it, there's just numerous cases where the CDN was like the first defense against the denial of service attacks. Some important cache control values. So I mentioned that the origin server returns these headers. It's not the only way to control the CDN behavior, but at least in my experience, it's the easiest one to deal with because it's your own server. You control the code there, so you can control what it does. First, there's private and public. You wouldn't return both of them. So public means that anyone can cache this content, whereas private is that any intermediary, so for example, a reverse proxy, is not allowed to cache it, but when it gets to your laptop, your browser can still decide to cache it. And that really depends on the content you have on your page. If you want to leverage the CDN, of course, you should return public. Then a no store and no cache. And I don't like the naming of no cache, but so no store means, of course, you don't store it at all. You don't store it locally, you don't store it on any intermediary proxies. No cache is a little bit different because you can actually still store it, but you have to validate if it's still fresh and if it's still the same data. So if we just jump in to the code, we can just have a look. So if I just do a curl for one of our resources, we can see here that it says X cache hit from CloudFront, it returns 200, and it also returns this E tag. And the E tag is any kind of value that origin says this is the hash of the content, or you could do anything. It could be a version number or something else you feel like. But basically, it's a value that if you send it again, if you do the request now, and then we pass this E tag back to the server, note here that it's downloaded a couple of megabytes. Now we say the same request, but now we get a 304, not modified, and no data was sent. So in this case, if we were using no cache, you could still avoid downloading several megabytes on your client. If you were on a Svelte connection, that would be nice. Max age says how long you're allowed to keep this data. And finally, immutable is a way for you to say that this data does not change. And that is really important if you have resources that you have some naming scheme, and instead of with index.html, the browser will always request the index.html. So you need to have it check every time, is this still up to date? So for index.html, you return no cache because it can still store the content. And then if it didn't change, you'll just get a 304 back and the browser will load from cache. But if you have, for example, a large JavaScript file, and then you can put in a version number, hash, something in the file name, and then you can say, hey, this is, first of all, public. Anyone can cache it. It has a very long max age. This is, I believe, 1 year. And finally, you say that it's immutable. So everyone downstream, they know that this will never change on this URL. There might come a different URL because you release a new version and it will have a new version number or hash up here. But yeah, it's a way to, instead of asking all the different reverse proxies around the world to flush their cache, you can just give it a new URL and then they will all get the latest version. Oh, I actually had a drawing on the E tag thing already presented it, but yeah, you pass along the E tag. The reverse proxy may go to the origin, but the reverse proxy might also still have a recent version because another client requested it, and then it can just return 3 or 4 if it didn't change. Some of the CDNs are also starting to provide more advanced functionalities. For example, this is an example of the Shopify CDN. They allow you to resize images. So if you have an image, a large image of something, and you can ship it basically one time to Australia, and then locally they'll resize it to fit a mobile phone or large screen or whatever you need in the front end. Cloudflare, they take it even more extreme, that you can basically deploy code on their edge nodes to get really good performance. Yes, then let's talk a bit about APIs, because if you just put all your static content on the CDN, and then you start calling your APIs, you're going to hit the cross-origin resource sharing issues. So cross-origin resource sharing is basically that if some client on my super CDN wants to call myapi.com, it wants to do a post to some path here, then the browser will, before that, do what it's called a pre-flight check. And it's basic security measure, because if it just allowed any malicious site to call any URL. It might steal your credentials and call this URL on your behalf. It will call the user management system and delete all the users because apparently you had access to that, but the malicious site will just use you as a proxy. What the browser will do, it will do an options request and say, hey, I'm about to do a post. Maybe I have some special headers. Maybe it's X track unit header, something. And the origin is my super CDN. Then the origin can say, hey, I trust my super CDN. So I return that, hey, that's okay, 204. And you're allowed to use this header and you're allowed to use these methods and you can cache it for this long. And then you do the post. That's an extra round trip. If you are, again, in Australia and trying to fit a server in name, then it takes a while for this round trip. What you can do is route it through your reverse proxy instead. You send a request again. You go to and says cache control no store because it's an API call. You don't want it cached. You want the latest. And it just returns it. So the reverse proxy simply becomes an intermediary router. Some of the benefits is that you don't have to deal with cross-origin resource sharing. So configuring less configuration. And sometimes you also get faster response time. The CDN providers are typically rather well connected on the internet, and they do a lot of stuff to optimize their routing. So where you have tunnels and smart routing techniques, and probably most importantly, that they can maintain persistent connections. So if a mobile phone connects and then 2 minutes later, somebody else connects to the CDN, they still have a connection open to your site, so they can quickly send it. Some of the challenges, you're doing SSL termination at the CDN provider, because how are they going to know what's in the traffic? They need to put the connection there and then look at the request. So you can get into issues with GDPR. Basically, if confidentiality is important, you don't route your API calls through the CDN unless you feel that you can trust it. But there are all these cases where, okay, can I then route my data through a CDN which isn't in the EU, and all kind of issues. Lots of these CDN also have configuration parameters where you can say that I only want to use points of presence within the EU, for example, or within a certain country. But it's a hassle. And of course, it is a new attack vector, because if the CDN gets hacked, they may inject something in the traffic that can impact your security. Yes, that was it. And then I believe it's Kasper now.
So I will talk a bit about Tailwind and a small NPM package called CVA, and in combination with that, something called TV merge. So at Track Unit, we decided to go with Tailwind about a little over a year ago. And that was to get a theming system that allowed us to do basically whatever we wanted in a way where we were not reliant on a specific framework, and we could build our own components without having to hack some material UI component library or stuff like that. So that gave me some pains, because this is an example of a plain Tailwind component in some JavaScript framework. This is Astro, it could be anything. And what you have to do if you have a button, you add a bunch of class names, and then you also have a variant prop. And if that is primary, I need to add these class names. If it's not, it's the secondary one, I need to add these class names. And I also need to add the class name prop so that I can override the styles somehow of this component. So this button is the one here shown with no tools, and this is the output of it, and we have an awesome secondary button in this case. This is a quite simple case. It might be okay to have this in your code. You might not think it's too bad because you can encapsulate it in this button component. But as soon as you have 8 different variants, and you maybe have a different style and have some compound stuff that's different between it, it gets really noisy and hard to read. So I will show you how this exact component can be done in this tool called CVA. And CVA means class variance authority. So you get this CVA function that takes an object. In this, you have some base styles, which are any class names. This doesn't need to be Tailwind, it could be anything. Then you have some variance object where you can add different properties on. And in this case, we have variant of the button under the variance object. And we also have a default variant. So if nothing is decided, you get a secondary in this case. So this does the exact same thing as the other code. It fills more lines, but it's more structured. One really nice benefit of this is that in this case, I can go in here and say, now I want the danger button. And then I actually get a type error because this is fully type safe and I don't have a variant of danger inside of my system. So before we implemented this, we had a button, it had a colors prop, and it just inherited from our Tailwind theme and said, I can do all the colors. But no one wrote the CSS whenever they added a new color. So you could say that, hey, this color needs to be purple because we have a purple color, but we didn't implement it. So when you go to the UI, you just have the default button instead of the purple one. Now that is not possible because it will say, hey, there is a type error here. We cannot compile this and we cannot push it through the build system. So that is one of the things that helped us accomplish. And then, of course, what we did was we didn't say, oh, you need to add the color everywhere. Just we changed the type of the button to be whatever made sense to have for the button. We don't want our button to be every single color. Good. So in this case, I have the page that shows this button here. And I actually have a class name on this saying that the background should be blue. And that class name overrides the existing classes. So if we go back into this demo, that's not blue. We can see these are the classes that's on the actual element. And it has a BG blue. The issue here is that Tailwind generates the style sheet based on the classes. And even though blue comes after the other colors in this class name, that's not how CSS works. CSS is based on the specificity in the style sheet. And Tailwind has an order for generating the different categories of their styles. So in this case, the background gray is actually more specific. It's probably lower down in the style sheet than the blue one. And that's an issue. Now you cannot override this without using important, for example. And that gives other issues if you need to override it again. So let's just jump in here. If we change it to pink, it works because pink is more specific than blue, apparently. Let's jump into TV merge. That is the fix for this issue. If we look in this normal CVA button component, I just imported CVA from CVA, the NPM package. In the TV merge one, I have a CVA config file. And in here, I have a hook that's incomplete. It gets all of the class names and it runs it through the Tailwind merge function. And you see the Tailwind merge up here. So now let's go in here and add the class name of pink to the button in the TV merge variant. And now we have pink. But if we look at the style list here, we don't have the gray background anymore. It was right here before. Now it's only the pink one. So Tailwind merge basically knows, oh, you're setting the background color. And then after, you're setting the background color again, so I need to remove the former background color. And that in the CVA function, the way it outputs the elements, that is guaranteed to be the lower down in the object it is, the latter in the chain it will be. But if you have special case, I will show that in the advanced example in just a bit. And then let's get back here. So pink worked, it also worked on the other one. So yeah, that's not that cool. Let's go back to the blue. And the blue also worked for the TV merge version. So in general, if you're doing this stuff with Tailwind and you don't want to use CVA, you can still use TV merge. If you want, you can just add the function directly to your class or class name in any JavaScript framework you are using. And you don't need to use CVA if you don't feel like you need the CVA part of it. And then let's go for a more advanced button. The case I had two variants of a button, that's not what you need in a button. You would probably have way more different things. So here we also have a button that supports disabled and transparent, and it had the two colors. And this is, if I just give it all the classes, it doesn't really work. I can't see what is the transparent version, and when I hover, I still get the hover effect and stuff like that. So if we jump into the advanced button. So this is the styles I have here. The style of the button says that, hey, if it's transparent, we need to set the background to transparent. But if it's a variant, we need to set the background to another color. I just told you that this is also using TV merge, and the order is the order it is in the object. So therefore, this background color overrides the other background color of transparent, of course. So if I comment out this one, and then I have the exact same object here, add it back in. Now the transparent buttons are actually transparent because it's later in the object. Cool. We still have the issues of this is still a white button. I can't see the difference between the transparent and the transparent primary and secondary button. So for that, we will use compound variants, and we will say that let's just comment this out so you can see it better. If the variant is primary and is transparent, then we want to add the text purple. If it's secondary and transparent, we want the text to be gray. So now we get even more of the functionality we want. And then we still have the hover effects on all of these buttons. So we will add in some more compound variants to say that, hey, if it's disabled and it's primary, or it's disabled and secondary, then we will have override the text color, or I'm sorry, the hover color, those two. And also, if it's disabled and transparent, we'll make sure that the background is actually still transparent. So now we have what we expect for all cases and all compound variants. So basically, all of these different cases, if you didn't use CVA, you would have to have a JavaScript function with a bunch of if statements or switch case or whatever to handle all of these edge cases where multiple variants crossing over each other. But these tools make it a lot easier for you, and you also get the full type safety. So I cannot say that, oh, if it's a danger variant, then no, this is typed based on the object right on top. Yes. One more small thing that it can do that I don't have in the demo, but in this case, I have added the props up here and said, hey, we have these styles and these variants. You can also use CVA to actually get a TypeScript props object out that you can just use directly from the CVA. So now CVA can define which props are allowed on your component based on the CVA you have created. And in many cases, you would do that by saying, oh, this is my button props, and that extends this CVA interface. And then you have one place, one source of truth that's inside of CVA. In this case, I like to be more specific and say, hey, this is the ones we have in the props, just to show it. And CVA is on CVA.style. You can go in there and have a look at it. I learned about it from someone working at Discord, and they apparently use it on Tailwind for the Discord app as well. And there is a beta version, that's the one we used in the demo. For the newest version, that's a bit different, a bit more updates and some nice features that is not in the current release version. So have a look at that if you want to play around with it. And then TV merge is called the Tailwind merge on the NPM. And also a really nice tool to have a look at if you're working with Tailwind or any other atomic design system where you have a lot of classes you need to handle. Yes, that was it from me. I did a speed run to make it up for Mads'.
Thank you.
5 minutes. Any questions for CVA or Tailwind?
When you build your own component libraries and use, I don't know if you use it, when you add this CVA, will you then again have React render the style
No.
the components, or do you actually have things?
It is just the output. CVA is just taking in your properties and it's outputting the class list as a string. So all the styles are still in the Tailwind CSS file that Tailwind generates. So you still have a static CSS that you download along with your app.
Okay. And you still gain the performance that you wouldn't if you would use some embedded styling.
Exactly. It's not like a Tailwind or whatever it's called, the other tool you can get where you have type safe Tailwind in your app, because that adds style tags on for every single component in your DOM. This is just a link to one style sheet that is generated once, and then this one small CVA function is of course running on runtime, taking the props, outputting the correct class list. So no big performance hit like you would with other tools, but still, of course, it is validating it with this small library CVA instead of your custom code. I don't know who's better, is the CVA developer or your custom code for the class list selection.
Just a comment on the Tailwind merge. It's not a free package to pull in. It needs to know all the semantic versioning or semantic behavior of all the Tailwind classes. So if you can avoid it, or if you do some quick front page or something, it would be a bit aware.
Yeah.
But you're just doing some big bundle anyway, maybe 5% bigger.
Yeah. And you can also get around most of it with these compound variants, of course. You still have the issue with the class names where if you need to override, you need to make it important.
Spacey colors and color space.
I'm here to tell you about colors. So what could be so interesting about them? I feel like we got that solved a long time ago. We got blue, red, yellow, you know them all. But turns out there's actually some new stuff, interesting new stuff in CSS. And it's a wider color gamut, it's called. And the current state of the art is called P3 or display P3. The one we use when we use something like RGB is the smaller triangle in the middle. As you can see, the smaller, therefore worse. You don't get all of these exciting colors out here. But of course, given that this is a projector and also I'm streaming it through Zoom, you can definitely not see any P3 colors in this image, which is a problem for a demo. It was actually interesting. I also wanted to demo these colors. Yeah, I wanted to display them. And I tried to muck about with the Keynote. And Keynote does support P3 images at least. But it cannot, at least I could not figure out how to set the color gamut. So I was forced to do it in the browser here. Yes, all right. So this is probably some color functions or ways of describing colors that you've seen before. You got the weird old HTML color names like goldenrod, and you got the hex codes. You got RGB, where you got the individual properties, red, green, and blue, and then you got some newer ones like, I don't actually know if they're newer, but maybe a bit more interesting like HSL and HWB. HSL would be hue, saturation, and lightness, which is a nice way to describe colors, which is more in tune with how we perceive them as humans. There's also some new ones. And these ones are way more interesting because they do not start from the perspective of a computer and what is easy to represent in numbers. They actually start from some studies we did on our eyes, human eyes. Turns out our eyes are definitely not linear in lots of has lots of weird edge cases and perceive some colors better than others. So building from that foundation, they build these new color formats based on the first one I'll bring up is LCH, light, chroma, and hue. And chroma you can think as the intensity of the color, lightness, and hue, I think you know what that means. Then you got OK LCH, which is a pretty okay version of LCH. It basically just corrects some weird edge cases that one had. So I'd say you can pretty much ignore LCH and LAB because the OK versions are slightly better. Yes, and I think OK LCH is a little bit easier to understand. If you wanted to represent the color, you could get it done just from mucking about with that, whereas the OK Lab is a little more weird since it has an A-axis that goes from green to red and also a B-axis that goes from blue to yellow. You probably can't really figure that out in your head up front, but it is useful for other stuff. So they also come with some new color functions in that is, I think they are supported in all major browsers now. This is how they look. For older browsers, you probably still have to have a fallback color. I'll get into that later. You can also do it with this syntax, and I think this has been supported in Safari since 2016 when they made the first screen that supported it. And this is actually very easy to understand because here you just use the color function and you say, I want to work in the sRGB or the display P3 color space or any future color space. And you set the intensity of the different values. So 100% in sRGB is the maximum a color can be inside that space, whereas 100% in the display P3 is slightly bigger. So that's what I've done here in this comparison. You can absolutely not see any difference here, but you can actually see it. So that's also a bit interesting because you should not be able to see that. And that is because, ideally you should not. That's because I have not defined a fallback. I just let the browser deal with it. And I think it does some, I don't know how it does it, but it's not perfect, at least when it collapses it into the supported color space for this screen. But anyways, it should be more visible here. I'll just bring it around so you can see it. There's some more. I'll try and put it here. There's some more. Blue, slightly less visible, still definitely visible. Green, it's quite visible. Yellow, not so much, I think. And purple, pretty visible here. I think that's the most pronounced one. All right, let's see. Yes, another thing that is pretty nice with these, I don't know if you've ever tried to define a gradient in the normal sRGB color space you didn't even know you were using. And you get these kind of boring gray in the middle. It's very annoying. It does not look like the exciting gradients on marketing landing pages. And why is that? It's because our eyes are as they are, and it travels through a lot of gray. If you ever seen one of these color wheels, the gradient would travel through a lot of gray parts. And then you can get the sRGB linear. It's slightly better because you don't get a more evenly distributed gradient. Yes. And it's actually interesting because this one is definitely not linear as seen from the computer's perspective, but it is more linear for your eyes. Then you got LAB. Now it's so annoying to watch here, but on my screen anyways, the lab one, you get some purple here in the middle, and the OK lab, you get it, I think, the most beautiful gradient here. They all are going from white to blue. So OK LAB, that was the one that was the weird axis, A and B axis, but turns out that one is really good for gradients. And then you got the LCH, which goes through a lot of purple, and the OK LCH, which goes through green. So that's also something you can decide when you choose a color gamut. All right.
Quick comment. So all of these are just saying white to blue.
Yes.
And the only change is the color gamut, color space. Right?
Yes.
So this is the same gradient, just the color space change. So that's why it's weird that the bottom one is also green, because from white to blue, you apparently that color space has green, because it's not the normal color we're used to seeing. No. Some sort of three-dimensional color graph.
Yeah, these ones go through a numerical color space. Try and imagine that. All right, so there's actually more interesting stuff with regards to colors, but I won't go through the rest here since we are slightly constrained on time. But you can also mix colors now. So you can say I want 20% blue and 50% red. So then you'll get the resulting color, and you can do that with some really nice color functions. I think this has been possible with what's it called, SAS maybe before, but now it's supported natively in CSS. Super nice. Number 2 here is one that I'm actually most excited about. You can define some really good looking color palettes. We just say, okay, these are my 5 colors, full intensity, and then you just play with the lightness variable, lightness part of it. And if you did that in sRGB, they would definitely not look pretty, because different colors, when you just mathematically adjust the lightness value, it does not look good. At least it does not look uniform across colors. But if you use one of these new ones, OKLCH, you will get like a perfectly looking color palette, and with maybe 10 lines of code if you have 10 colors. Yeah, super nice. What else? Yes, Figma recently added support for it, which is late. Sketch has had it for a long time, but it just has not really caught on before now. I don't know why it happened all of a sudden. You can use it now. There is if you use Tailwind, it is not, you can make it work, but I say, and that's I guess what we do, we're gonna wait a little bit, because Tailwind's next version, which is they call it Oxide, the new engine, it will support generating these fallbacks natively. So you just say what you want in the P3 space, and at compile time that will add a fallback. I think it's like add supports P3 color space, and then if not, then we'll render the other one. So that's pretty nice. Yes. How much time have I spent it all?
You actually have 10 minutes left.
Okay, then I will definitely take you to this one. So this is, if I had a million years to do my slides, I could have done this instead, but somebody else did it. It's actually interesting. These are different colors, even though the screen does not support it. I guess that just means they are both worse than they are and how they should actually look. But it's interesting.
It might be the zoom compression that's recording your screen, seeing the difference, and then changing the colors.
It must have to be. That's weird. It's very weird. But here you can see this is what would normally be a square, perfect square. If you use one of the boring old ones, you have seen them with the color. You can pick a color in the square. But this is more how our eyes work at this color. So let's go to green here, and you would. If you stay within the sRGB color space, this is what you get. And up here, you can get some more interesting green. And I'd say it's quite striking. And maybe you should not overuse this for maybe don't make every color, every button this color. But for example, for a marketing landing page, it can look really incredible. You also see that some colors has a bigger difference than others. Yeah, you also saw that before actually when I took you through the slides. Let's see, I could maybe also, what is it called? No, it's just an example of a pretty cool landing page that has free support. At least on my screen, these colors just look out of this world when you're used to seeing stuff in sRGB. Yeah, I don't know how yeah, obviously can't see that, but anyways, I think that's it for colors. Any questions?
Maybe just a comment.
Yes.
You mentioned it a couple of times regarding browser support.
Mhm.
I see, at least for Chrome, it's supported since March 7th this year.
Yeah.
So it's
Pretty
still quite new.
Yes.
But 85% of all browsers support.
Yeah, and that's why it's good to have a fallback strategy.
The browser will do.
I actually don't know about old browsers that don't even know about it. I don't know. Yes.
How many devices and screens support showing? You know, the cost.
You gotta look. I think most Apple products do now. I think all as for a long time actually.
92% of phones.
Yeah, phones definitely okay.
83% of desktop.
That's pretty good.
Most.
Yeah, that's nice. Of new
Global.
in use.
It's a browser support, right? Because the browser
That's not the same. A screen has to support it. The actual hardware has to.
Old laptop.
Yeah, they definitely don't. So it is a nicety. You can definitely do without it. Say you get up if you use the gradient stuff, you still get to avoid all the gray parts of the boring gradients, even if you can't show it in the full color spectrum. So that's the right.
And next up is harness the power of NX workspaces.
So we go over here. There's no room because of the plant. We're going to talk about how we are using NX in different projects. Both Bjarke and me, Tim, are consultants. So we work with different companies in different domains and etc. And we migrated many of our customers to use NX. If some of you have joined these meetups earlier, you might have heard NX several times. But let's dive into it. I think if you summarize me and Bjarke, we are almost alike. Bjarke is just a bit older. I think that's the main difference. And yeah, we work at Trifork, big company, at least if you count on number of employees, but are more like a startup. So each division of Trifork is more like a small company, helping the local companies around that office. Yeah, let's skip those. Yes, let's talk about the 5 cases where we migrated some of our customers to use NX. Some of them starting from very small and maybe don't even have a project. Some of them had a big project but wanted to migrate. And some of them even had their own kind of Monorepo, maybe with some old tooling, etc. But maybe one key point, if some of you are considering migrating, that's also the selling part, because it's not only the developers that need to be sold on the idea of migrating, because it will take some hours to implement. Then of course you need to tell your CFO or whoever it is that manages the money. So now hopefully you'll have some more ammunition. But let's take one of the first examples. We had, or we still have, Kingspan as a customer. We had a big app for them that we did. It's a big calculator app that calculates how much power you would save if you upgraded your varmerørsledninger, whatever that's in English. And yeah, that's a big calculator for that. And that's all good. And now they wanted some new other apps that's been the same domain, but they want them as completely standalone. So we didn't really have a way to share the components, and it's supposed to be different apps, etc. So even though the project wasn't that big, we actually migrated to NX. So now we have 2 apps, completely different purposes, but they're styled alike, and some of this calculator stuff is also shared. And they can deploy them individually, and it's just way easier to start new projects. So there's already lots of new ideas for other small tools that they would like, and we can certainly give them that for only a percentage of the development cost is only a percentage compared to previously. And each time you add a new project or whatever the ideas they get up with, we actively maintain all the shared logic. So all of the apps becomes better each time. If they were just in different repos, that's not as nice and easy to do. Yes. So I think let's just sum up of one of the small changes in setup we did. A bigger one is a tool or internal code name we refer to as Leopard. It's a one huge React project, as in it's 5-6 years old and actively being developed on in all those years. Tailor-made for one domain, one customer, and everything is just custom. But because this is now such a big, nice tool, we want to convert it into something generic so we can start resell it. There's lots of classified domain in the code. So there's this struggle that we need to do something generic while still developing the ultra custom one, but also be able to, in the near future, actually release this as a more generic platform. So what we did in this scenario was to pull all the shared code, and shared code is the components that they don't know anything about the data. They know what they expect. So if it's a table, well, give me a list of columns and give me the data and I will show it to you. Give me a map. I don't care where in the world or what polygons or whatever you show on the map. I'll just show a map. All those kind of components, put them into shared. And then we had the shared actually on a completely different repo because we couldn't really reuse we use GitLab for the private stuff, but we can't reuse that to our data platform. So we also have two different repos for the shared ones. Then each time we build something in this shared space, it's bundled and everything as an NPM package, still privately within GitHub, and then just installed as was it any other package or private setup. And to make that work, we did a custom generator in NX that makes it easy to basically bootstrap these packages to make them deployable on GitHub private repository with the correct tags, etc. So that's some of the nice things about NX, that if you have some specific use cases, even if it's not very big setup or anything, it's quite easy to do these generators yourself. But one thing to keep in mind when you will put it out into two repos is that you have the same requirements as if the code was entirely public. You need to have some idea of when are you actually breaking the interface. You also need to be able to test your code without pulling it into whatever, or pull it into Leopard, for instance. So what we have is a storybook. So the shared repo is all of the components and the storybook that can show all of these components. And the theming and the data and whatever, that's just some fake data in that storybook, and we can use it in the real life in the other project. But with all of this setup, we also have all of the tough components. They're out in shared components. So now it's actually way easier to start developing this data platform that's much more generic. Because that's the goal that we have, that we shouldn't know anything about the data. That's just metadata. So just show it. And we're quite far on that journey. Yeah, so we have 3 apps, the Leopard, the upcoming data platform, and then the storybook to show those apps. And then 12 packages and 6 developers working on all of this Gatehouse.
And then we had a case with Gatehouse, specifically a maritime, where they have an old front end that's deployed on-prem for their different clients, basically like a giant map with lots of different features on what to show on this map. It's written in HTJS, and it was becoming basically impossible to maintain. There are 1.5 developers on it currently, so they needed something new that could allow them to work faster in the future. And so we had a lot of talk talking with them, and they wanted something where they could feature flag stuff based on where it was deployed. There was also some talk about using micro front ends, and basically we ended up recommending NX because they are, I wrote 2 developers. I think it's 1.5, both in the room, and we decided to basically rewrite the whole thing in React. And then because we also knew there was possibilities of some smaller one-off apps, that allowed us to introduce some shared components that could be used by these. For instance, we wrote a wrapper for open layers with React that we put in a shared component, so we can use that both for this one-off app that needs very little from the map. And then it was also, like I said, it's a very small team maintaining both these apps. And we basically recommended not to go with micro front end because 1-2 developers, micro front ends, we would need a lot more to just host this solution. And so we also needed to be able to do the deployments in places where there's no internet access. So it didn't really give much benefit. So we ended up doing, right now it's 2 apps and I think 13 packages or something like that. Is also, they can share API packages as well, which is really nice. Then we did the same thing for Nuclear. They have many repos. Basically, their philosophy is every app they deploy is a repo. They have one repo though where they deployed 4 apps with a landing page. So there's a landing page, which was a single app, and then they had 3 other apps that basically used the same APIs to present views in different ways. This for this basically mortgage stuff. If you are using Tailwind, they developed all the internal tools for when you get a mortgage, remortgage, refinancing, all that stuff. So this repo was basically a monorepo. It was using Learner, it was using Create React App, and then CSS modules. This caused some issues. They had some self-built scripts to combine these multiple apps into one deployment, and then they had a few very large shared packages. I think they had 4. One was basically, it's called shared, and it had everything. It had the UI components, it had API fetching components, it had some testing in it, and so it caused quite a few issues with tree shaking. Every app had a lot of unnecessary stuff in it. From a developer standpoint, it was absolutely horrible to check out somebody else's code. So if you had a PR and you had to try some things, before you could even start the app, you had to build the whole repo for 5-6 minutes. And so that meant you didn't do that. You reviewed the code and it was like, it looks good enough. And also, if you had to do any changes in these shared packages, it was very cumbersome because you had to compile that package before it was then brought in to the apps. And then furthermore, each app had its own set of dependencies, which meant you could be running one version of React in one and another version in another, and it was basically a nightmare. So like I said, they ended in 3 apps with different data, basically using the data for different purposes, and then a landing page. Then they had some API that was shared across all the apps, and a lot of shared components. So with NX, we managed to be able to basically, from you get the code, run npm install, and then you could just start the app and it would just work. You would be running within 15 seconds. And so that meant you could easily check out a branch, npm install, and then run it. We also, with NX integrated Monorepo, we basically were forced to have only one version of every dependency, which does mean that whenever we have to upgrade, we have to make sure it works well in all 3 apps. But the headache it's a lot less headache of knowing what version is then actually used, because we were basically forced to use yarn resolutions in order for fixing issues before that. So right now they have 4 apps and then 5 shared packages, but they are moving into we're looking into splitting up this big, large shared components into more focused packages. Another really nice benefit of NX is that now you can, if you have an import, you can command click it and go like straight to where that code is before you were put into the dist folder and had to then find your own way from there. They're very happy with increased, what do you call it?
Developer experience.
Yeah. And then once I had shown what that could do, they have this design system, which is an open source UI component library that they use. It's called RMW, basically wrappers around material design web components. So they use the official material design web components library as foundation, and then they add some wrappers onto it so that you can use it with React in a nice way. Then this repo had some minimal learner. Basically, learner was used to update the version in every package. That was it. Then they used some very custom build scripts and also create React app rewired, which meant they were fiddling with Webpack in order to handle deployment properly or publishing these packages properly. Each component is also published independently, and then they have one shared everything package. So if you want everything, you just npm install that one. And the goal was to not have any breaking changes. That's still a work in progress, but we have 43 published packages, and we have 2 helper packages for doing the README, and then we have 1 app that is used for documentation purposes. While we were redoing this, we also found a lot of cyclic dependencies, so cleaning those up helped a little bit with bundle size. And yeah, so I wrote 3 developers, but that's based on who are actively maintaining the repo. This is still work in progress, and there are some issues with CSS that I am still trying to figure out. But for this, it was very nice with the whole dependency graph of NX, which really helped me figure out like what packages depend on what.
So to sum it all up, the 3 main reasons we see to migrate, it changes your mindset. Instead of just we are building one big application and we just need a new component that does this, etc. You just end up creating lots of one-off components. And yeah, you get something working nicely and it's great. And the week after and the month after, it's where did all these files come from? It's just one big mess if you just keep adding these one-offs. So with this mindset of we have something called packages. When I start developing something, is this a package? Maybe it is, but just that thought, think about, well, how should I actually structure my code? So whether you use NX or some other Monorepo setup, it doesn't really matter, but just the mindset of we have a way of actually structuring some components that can be reused, and the less code that's in there, the less code we can reuse. So that's something to have in mind. And that's a good way to sell to whatever your management likes to hear. Easier to scale. Well, the more you put in those packages, the more love and energy there is then in those, the more components you have to build upon. So these small new ideas that sometimes comes from management or whoever, it's just way easier to bring something quickly to life. And even with building something that's big, you have something that's easily maintained because all of these packages, they just become more and more stable because you use them in so many different ways. And when you do all of these packages, you put the tests closer to where that, so if you build a table component or whatever, the tests for that component is usually next to it. In that way, your components also become much more structured. Then we use NxMigrations a lot. It's a thing in NX that can help you maintain your dependencies and your configurations. So it's not just running yarn upgrade latest. It's actually, it's upgrading Storybook to a latest version. And Storybook also has some new configuration. Then it goes to each of your packages, updates the configuration to whatever is the new way to do it.
So in that way, it's just easier to stay on top of dependencies, especially if it's some projects that's maybe it's not being worked on every week or month or whatever. Then you can almost do these NxMigrate layers, and you're sure you're actually up to date. Try doing that with a config. That's hard. Yes. So lots of small wins. It doesn't have to be a huge NX setup as here at Track Unit. Even small teams can actually benefit from this. If you see the project you're working on, either we are going to make multiple apps that have something shared, or we know, well, this is going to be a long runner. Consider NX already at that step. Yeah, and some of the stuff you are struggling with now, to actually make it easier to migrate to NX. If you have that thought sometime, try to make your build pipeline as simple as possible, because the less code that's in your build pipeline, the easier it is to change again. So if you're thinking, I just need this node script to build this and move these files, and then it's going to be a headache to replace it. So that's just something to have in mind. That's it for us.
All right, in the interest of time, let's get started again so that people can leave in half an hour if they really need to. Otherwise, it's completely free to stay and chat afterwards as well. You just asked, so how many lines of code and projects are you up to in our case? First off, we don't only have a monorepo, we have 200 repos. We have one for all the TypeScript code, and that's using NX. And we have 250,000 lines of code. We have 573 different projects in that repo. We have 217 extensions. I'll get back to what that is in our platform. And then 120 different applications in that repo. And one pipeline. And we release it many times a day.
And 47 developers last month.
Yes, 47 developers last month working on the same repo. So NX does scale, but you have to think about how you scale it. So don't put translation in one library or in the bottom of your tool chain, because then every time someone needs to change that one comma, all 120 apps needs to be redeployed. So you have to think translation has to be built in the top of the tool chain. Same with feature flagging. If you want an enum for all your feature flags, then you have to build that enum in your application. 120 different applications, not at the bottom of your tool chain. Same goes with GraphQL calls. We've been using GraphQL heavily internally, and we have one big library with that has all the queries. That means that every time someone changes one comma, 120 applications redeployed. So we're changing that right now, making sure that we put all those queries into each of the individual apps or the projects. And then only if they need to share, then they can of course share, but then use NX to share those queries from one library to another. That was the answer to that small comment. So I'm going to talk to you about something completely different. I'm going to talk to you about Webpack bundling and module federation. And I only have 15 minutes or 14 now. So be quick. So navigating Webpack bundling is important if you start to get a bigger and bigger application. When I started, we were using, and we are still using, E-charts, I-charts, some other charting library, and moment, and date functions, and PDF, and Excel, and all of that is bundled into one big application. So when you're talking about Webpack, it supports bundling. I assume all the other also support ways of bundling your stuff together. So you can't read it up here, but here it actually says there's some caching groups. There's something for Excel, for E-charts, high charts, moment, octa, date function, and then render. Render is the rest that didn't catch everything in here. And then there's, of course, our own code. So if you use Webpack, you can actually visualize it using something called Webpack Bundle Analyzer. If you put that into your plugins and say, hey, just do a static code analysis on this, you'll get a website page loading like this. And here you can see our vendor bundle has a lot of bigger jQuery, Lodash, ESM module, PDF, JS-zip. I don't even know what we use that for. And then we have our main application, right? So this is actually the stuff that we wrote. And then this is the vendor bundle. And then we also pulling in octa, moment, pie charts, e-charts. These are both charting libraries, Excel. And then all the other ones out here, they are lazy loaded pages. So in order to load up our login screen, you need the main and you need some of the vendor bundles, whatever the main needs. So it's important to think about how you split your things into smaller pieces. And you might think, oh, we have it under control. I'm using React lazy loading, so it can do that magic for you. But then you have that one page that is lazy loaded that then imports something from another library that then imports something, and then you get everything into your main module anyway. So you need to be careful when you build this out. This can help you analyze if I didn't do that grouping in here, in my Webpack, I would get a bundle where the vendor bundle was this big, and then the main was this big. You want to have these more or less the same size, because then the browser can download all of it at the same time. It can't load a million files, but it can load at least 10, 15 files at a time. So it can load all of these at the same time. So try to make sure that you think about the sizing of this. And this is an excellent tool. You just run it and then you get the answer. How does that look from my page? And the reason why we have all these out here is because it's lazy loaded. So the fact that I'm using React lazy loading, and React lazy loading is, if you look at this application out here, you could say that when I click on this menu item, then I'm loading in something in this page, right? And this page is then maybe it's this one. So it's not loaded in order to show the login screen. Then I only need the main and some of the vendor stuff. But when I click the menu button there, I ask React to lazily load this specific page, which is really nice, but it also gives some headaches. And one of the headaches is that if you think about, okay, we build everything, we have all these bundles, and we ship it to production. I then render this page on a different, this site on a different page, and then Anders goes in, does a change, and releases that to production. That means this specific page that I'm going to click on is now a different JS file, right? My browser has a version of the main where the main says, oh, you need to download version X of this lazy loaded module. Then lazy loading goes in and says, oh, I'm just going to catch we've implemented it this way. So you have a retry. So if you get any error, just reload the page because the browser has already gone to the other page. Then when you reload, it will go and get the latest main. The main will say, oh, I need the version that Anders built. And then it works. So the user doesn't see it other than, oh, when I click this magic button, it just re-renders, reloads the browser. But you don't get those irritating headaches for the user. They don't see it. And if you release every day like we do, you want that in there. Yeah, that's it for chunk loading errors. If we move on to something called module federation, it's a separate topic, but it's trying to solve some of the same benefits of this lazy loading. It's trying to decouple things. Module federation can do it, I would say, to the extreme. It has all the benefits of web performance and can build independently. So you really want to have something like module federation, which is what solves micro frontends for you. So what it does is it supplies some interfaces, you could say. So inside the host application, we'll see that in a minute, I'm able to import a button and a use store by just using a normal import, just like you're used to in NX. And this remote app / button is then pointing to, oh, remote app. So that comes from my federation package saying remote app is actually this remote entry JS file. So it's a JS file on the network. It needs to understand. Then in the remote version, I have a completely separate deployable unit over here, and I can expose some functions or code. And here I'm exposing the button and the store so that I can import it over here. So the button is just a normal React button. I'm just exposing the button here and making sure that if anyone wants to use this, they can read that from this remote entry JS. So this is like what Webpack does for us, right? It bundles stuff together for us. Now, module federation is so cool that it can understand shared libraries. So if you're on the same web page and rendering the remote app and the host app, then module federation goes in and says, oh, you asked to share the React code. Then I don't need to download the React code again and load it into the browser because it's already there. So the minute you load in this remote, it doesn't go and pull in React again, because that's really not what you want. But if it's missing, then it knows that it has it available, so it can always say, yeah, okay, it's not there yet, so I'll just load it up. So it could be Yotai, that's a library that's being used over here, but not in the host. And maybe a third version, our app is also using Yotai. So it'll just be whatever is hit first in the browser. We're just loading that library, and then we'll only have one version of it. If we look at how we do it here at Track Unit, we've implemented our own API on top of Module Federation. And it's complicated to cover in 5 minutes. There's a page called developer.trackunit.com if you want to read up on how it's all working. But essentially, we're trying to get to the point where we own the host out here. That's the main application. And everything that's in here is owned by you. So external companies can contribute into our application using Module Federation. Now I just showed you that, oh, we can share code and it's all good. And React is only going to be loaded once. And then I'm going to say we actually use iframes here. So it circumvents all that. But it doesn't circumvent it more than we wanted to. So we own the iframe. In that iframe, I use Module Federation to load up the package that you built. That means you can build it and use our button component by importing that from my NPM registry. Then if I decide I want to make the button blue, I can just inject on that Module Federated page in the iframe, I can just inject a new version of the Track Unit button package. And then your code will not change. So as long as the interfaces are identical, I can inject stuff into this page that you built 2 years ago, and I can just update some of the code snippets using Module Federation. That's one thing. Let's say in 2 or 3 years, someone comes along and builds something that's even better than iframes. Not as convoluted to work with, but still isolated, because it's the isolation that we need when we're talking about external engineers building on top of our platform. So that's what we built. We've identified cases of our UI where we said, all right, here, we don't want to make it part of the host. That means our host application is not 250,000 lines of code. No, it's way less, and it starts up within 30 seconds. Once you have the host up and running, you can then say, oh, I need to build something in this specification page. All I'm going to do is start that up and get that running. The combination of the host and this specific extension points then allows you to run that locally. For external engineers, they don't have our host code, but they can run against our dev environment and say, yeah, I want to run local. And that allows them to run their code in the browser using our host application. So what is an Iris app? I told you the entry point of a module federated package is actually a JavaScript page or a JavaScript package, right? We also supply or build up this manifest. It's just a JSON document statically telling us how to render it in this application, because the menu bar out here we want to show instantly. We don't want, it'll just ask your code. So should I show this for this specific machine? And then it'll keep spinning for 5 minutes, and then your code returns and it says, yeah, I'm going to show it. No, we want that to be instant. So the menu can be displayed instantly. And then when you click on this specification page, which comes from the manifest, remember this is static code, just a JSON file. Then we can say, all right, when you click on specification, I'm going to load up this iframe, and then I'm going to load up your code. So again, the host is not dragged down performance-wise. We're not pulling in more than we need to. It's in an iframe, so it's isolated. So the minute you go away from this page onto another one, those resources are cleaned up. That's just another representation of more or less the same. So we have the host, which includes what we call an Iris app. It's the iframe loader. In here, the Iris app is now, in this case, it's a feed extension. And this is the manifest that we're building up. So the menu item has a name and an icon. We also support translation. We also have some conditions that you can put in here and say, oh, if your fleet has the brand Manitou, then show this. Or if you have Skyjack, then show this, so that we can have people pick and choose what they want in their product. And then we put it on a marketplace so that our end customer can look at that marketplace and say, yeah, I want to buy this, access to that feature, this feature. Or they can talk to consultant companies, and then they can actually go and build private stuff for them built into this application. Do I have time for demo? No.
You have 1 minute, otherwise you need to fight Anders.
I'm not going to show it. I just wanted to, yeah, I'm going to show it.
Eat the black belt.
Exactly.
Have it, right?
Yeah. We have a very short demo here, so you can't see anything. So we have the host here, which has that weak config, where we had that talk about, okay, we have an app that is using remote, and I'm just going to show the app real quick. So here we have the host application. It's embedding that button that we talked about before. And if I shut down the remote, I'm in the remote folder here, then the application simply doesn't work. Of course, I would have to have error handling for that, right? But let's say I keep the host running, and then I'm going to go into this and say now the background button is red. I don't. And then I'm going to start up the remote again. So now I have a new version, and I'm refreshing the host. So I did not redeploy the host, and I'm able to remote. So using module federation, I can actually have different applications running at the same time if I just need a way to host them, right? In this very simple example, we're actually hosting a web server for the remote and another one for the host, but actually it's just the remote entry JS files that needs to be hosted somewhere and then linked together. For the track unit platform, we're using an NPM registry and deploying versions out there. So all these Iris apps, they actually just published to an internal repo for that. And that was it. Any questions?
Okay, I'm going to talk a little bit about Svelte. So let me give a short presentation about who I am. My name is Anders. I'm a freelance software developer, and I love web development. I've been doing a lot of Angular development, and I love Angular, but it was perhaps getting a little bit heavy and a little bit stale. Things have changed over the last year, though. So I found something else to throw my love at, Svelte. Can you move this away? Here we go. Good. So the practical stuff, I have limited time. So if you have any questions, just hold them until the end, or you can come find me afterwards. And the slides are available at that link. They'll be at the end of the presentation as well, though. So these 20 minutes will be a bit about history, like the general term of history, about what Svelte is, how you can use Svelte, and then the next steps to take if you're really interested in what I have to talk about. I won't be able to teach you all of Svelte. I'll be able to teach you a little bit about it, but hopefully it'll pique your interest. Okay, so all good histories start with once upon a time. Computers were huge. If we go back to the 50s and early 60s, these computers you were looking at were really big machines. They were using vacuum tubes. They would take up a warehouse floor or a small residential house. So not something you would have in your home because they would be your home. Okay, so in the 60s and 70s, you saw something new emerge. You went from vacuum tubes to microchips, and computers would become what they call mini computers. They would not be computers as we understand them today. They wouldn't have a screen and a keyboard. They would have teletypes, which are these printers with a terminal interface where you press keys on the keyboard and you would print on paper, send that data to the computer, and the computer would process it and write stuff out on paper. It would have very limited amounts of storage. And again, they would be relatively large. They could perhaps fit in a cupboard or a couple of closets. They wouldn't be an entire house. They would still be big, and nobody would have them, or at least companies would have them. The first computers would be big, they would be expensive, they would cost millions of dollars to build. The mini computers would go down an order of magnitude, so they would perhaps cost something like $100,000 or down to $18,000 the PHP PDP-8 machine would cost. So that would be where the computers would be in a price range where companies could buy them. But again, private people wouldn't have them. So then you go to the 1970s, and I don't know if you recognize that machine. That's the first Apple computer. Design-wise, they have moved far from that, the same aesthetics, as you can see. So this would be the first time where you could have a computer for yourself. And when I say yourself, you would be a geek or nerd. We are all geeks and nerds. Now it's a positive word to use about yourself. Back then, not so much. If you'd have a computer, you would have it because you thought it would be really cool to have one and you wanted to tinker with it. And when I say tinkering, it wouldn't be writing code. It would be basically soldering stuff onto a main board and building your own computer. And most computers would be in kits. So normal users could, of course, buy these machines and they would come assembled. The first Apple computer would come assembled as a PCB board that you could hook up. But it would be difficult for a normal user to find justification to buy one because what would you use it for? You wouldn't know it would be a computer. Geeks said it was cool. You didn't know what you wanted it for. You would need something that would be a killer app, something that would justify you to spend a large amount of money on a computer. Again, computers were cheaper now, so you can afford them as a normal person. In the late 70s, early 80s, this machine would come out by Apple. It's the Apple II, which was their one of their really great selling products, and it had a killer app, so everybody wanted it. The killer app was called VisiCalc, and it was a spreadsheet. So nowadays people would look at me and say, oh God, not spreadsheets. The entire world is run by Excel or online spreadsheets, and it's not very cool. Back then, this was the biggest productivity boost you could have. If you were working in accounting, you would be working on spreadsheets, but it would be on a piece of paper. So you would be doing a spreadsheet and it would take you an entire week. If you had to change something, change a column, you would have to do the manual calculations, find your eraser, erase all the text on the paper, do the calculations, and you would do another week's work. This was a huge killer app because it would now do all the calculations for you based on input. So you could do something that had first taken a week down to a couple of minutes. There was one problem though, VisiCalc was slow, but that didn't really matter because when you look at performance, it's always relative to something. You would say, you've never seen something like VisiCalc before, and you would have something that was very fast compared to the manual step, so it would seem very fast. Unfortunately, things in computers move really fast, and back then they would move more faster than it does today. The Apple II computer still existed, but the IBM or PC computers, personal computers, would appear on the 8088, 8086 processors. They would have much more performance, and this new spreadsheet app would appear and it would run on the IBM PC or the PC clone. And it would of course be faster because the new machine was simply faster. But it was also faster due to other things. In VisiCalc, just imagine it as your regular run-of-the-mill Excel spreadsheet. You enter in stuff, enter in data into some cells, you enter formula into other cells. And when you update some of the cells or the formulas, you want to recalculate that. The problem with VisiCalc was that it wasn't very clever about it. It would recalculate everything. And being on a limited machine with limited hardware and performance, it would just be slow. Lotus 123 did things a little bit differently. They used something called reference forwarding, which is what the name implies. It would examine the formulas and the dependencies between cells and just do the calculations depending on where you change stuff. And that is reactivity, reacting to changes. If you're reactive, you're more performant. So there's an unfortunate truth I have to tell you that all the most popular web frameworks today aren't fully reactive. I'm sorry, don't cry about it. I'll fix it in a couple of minutes. React is not reactive. You would assume it would be just by looking at the name, but it's not. It has a virtual DOM that is then analyzed against the regular DOM. So when you change something, you'll compare the two DOMs, traverse two DOM trees, and then manipulate it to see the changes. It's relatively performant, but it's not reactive, so we can do better. What about Angular? Angular is not reactive. Angular is probably worse than React because in Angular you have it's a change detection mechanism. And if you understand that fully, please come and explain it to me because I keep getting tripped up in the way it works all the time. The view engine is great. It's reactive. It's just detecting the changes that aren't reactive. So again, Angular is not reactive. What is Svelte? You can probably imagine what's coming next. Svelte is reactive. It means it's it's also simple to use, apart from the fact that it's reactive. It's fast because, as I said a couple of slides before, reactive apps are fast. So that sounds all good. So how's it simple? These reactive constructs we talk about are usually a bit complex to understand or reason about. React have hooks. If you understand hooks, great. But they can get confusing at times and lead to mistakes. Angular uses RxJS. That's not a simple framework by any means. So instead, Svelte has taken the approach that it'll just let the compiler do the hard stuff. And by letting the compiler do the hard stuff, it will basically analyze your code and just produce if statements from it. And as we know, if statements are really fast. And by the way, it's also simple to set up. So if you want to use TypeScript, it has that out of the box. Don't worry about it. Okay, it's also fast. So why is it fast? It's built on a fast tooling. It uses Vite for the builder, bundle, the environment. And Vite is fast due to a number of reasons. It does really intelligent bundling and processing of source code. It's also fast because you write simpler code. And if you write simpler code, you have to think a little bit less about it. And yeah, it's just fast. So I'll try to teach you Svelte. And Svelte is not that difficult to learn, but you need a reference. So all the examples, or most of them that I go through, will have a reactive example, an Angular example, and then let's have a look at how you solve it in Svelte. I'm not going to go through all Svelte because, let's face it, yeah, we don't have time for that. Okay, so first and foremost, if you use Svelte, there's one simple rule. Svelte is a framework built for making components. It's not built for making single page applications, at least not out of the box. You need external dependencies for that, just like you do with React. But you're able to create components. So you create a component or one component per file. The components have to be named uppercase. You could probably name them lowercase, but it's not convention, so please don't. And the files have to end with the Svelte extension. And your file contains three main areas, if you like. It contains a scripting area that contains your JavaScript or TypeScript code. It contains your markup, and it contains some styling. And the styling is, of course, isolated from everything else. So every component you want to do needs to take input. In React, we know how to do input. You add a props to the constructor of your component, and then you're able to interpolate that into the JSX or TSX file. In Angular, you decorate your components with an input decorator, and then you're able to interpolate with a couple of extra scripted parentheses. In Svelte, it's a bit simpler. In your script, you say export whatever you want as an import. That's not logical, but that's the way it's done. And then you just interpolate it in the markup. And I know this is a bit confusing because we normally see export in ECMAScript modules when we actually want to export something. So you can say that you actually export an input. I don't know. That's how you do it, at least. So very simple. Okay. So if we talk about input, we also need to talk about outputs. In React, I created a small example where I have a button. And when you click on the button, you can have a callback occur. And you basically just interpolate the function that you want to call back based on the other component. And it just works itself out. In Angular, you can create a component, have it output something based on the output decorator and creating an event emitter, and then just invoke that and basically have it output the event you specify. In Svelte, again, I hope you can read this. You create an event dispatcher, and then you just call that with the name of the event you want to emit. And of course, you can add payloads to that. You can do that with other stuff as well. And again, like 4 lines for the component emitting an event. And then as in React, you just interpolate the function you want to run on the output or the event when it occurs. You may want to have a look at, let's see if this works. No, it doesn't work. No one works on my Mac. Okay, I'll point instead. On : is basically a directive. So Svelte has very limited number of directives and you can't create them on your own. So on basically just says, just handle the event that occurs. So that's how you hook into that. And you can see that we dispatch the clicked event, and that's what you handle here, and then increment some counter stuff. Okay. I talked a lot about reactivity and how it was difficult in other frameworks. So again, in React, we use hooks. I won't go through this example in great details. In Angular, the developers lost their mind. That's my explanation. They do some really strange imperative code stuff where you have an interface you have to implement, handle some sort of strange object, and then do stuff. It works. It's just very verbose and manual. In Svelte, again, it's really simple because you use the compiler. If you have something, a button you click and you're able to increment a counter, this is what happens down here. When you click it, we increment the count variable, and then we print out the doubled value of the clicks down here. So when you want to do something reactively, you just prefix it with a $: which is a JavaScript label, and the compiler will then analyze what needs to be done to calculate the double value. So it will see, okay, I have a dependency on count. This is again reference forwarding as Lotus123 did it. And it will basically just create an if statement. So if count changes, let me redo that. Now this is really simple. This is just a statement, but you can have code blocks. You can have any statement you'd like, really. And it'll just analyze the dependencies. And it works great. Just don't pull out anything you have after the reactive label into a function, because the compiler can't figure that out. Is it okay if we go 5 minutes over time? I can talk fast, but you won't be able to understand it. So, of course, there are lots of other stuff. There's these logical blocks you have in the Svelte engine. React doesn't really have any support for statements because it outputs a value. So if you want to do something with an if statement, you basically have the ternary operator, or you can decide to return something based on an if statement, but it doesn't really have support for anything like if statements. In Angular, people again lost their mind. That's the pattern in Angular, or at least they thought, let's do this as extensible as possible. So they have something called structured directives, where it'll de-sugar whatever's in this attribute and then create templates and evaluate that. It works. It's not very elegant. So in Svelte, again, really simple stuff. You use the curly brackets to again say, let's interpolate some behavior. And there's different ways of looking at this expression language add. It's a block of logic or it's a beginning of a logic block when it starts with the hash sign, like here, the F statement. You can append to that logic block if it starts with a colon, like the curly bracket colon, and then you basically end something with the /. So again, this should read relatively easy if you compared it to imperative code, like if, else, and then you have a end curly bracket at the bottom. You have loops. Again, React don't have loops because you return a value. So you have to do map, or you have to do other stuff before you return whatever your DOM is. Angular, again, unfortunately lost their mind and decided to do a structured directive. It works, but figure that out. Svelte, on the other hand, said, let's do a logic block. So let's just read what we have here. It's curly bracket, the hash sign, and then you have the each logic block. And it reads like the for auth or the for each statement in JavaScript. It does have one nice added feature. It has the support for an else block, which means if there's nothing in that members array, it'll just print the other stuff. So you don't have to nest an if and a each block. Again, convenience. The special handling for promises. It seems like both React and Angular lost the marbles there. I have no clue what's going on. I do, but I don't want to go through it. Read the slides, please, especially the Angular one. Svelte, again, takes the easy approach, created a logic block, has an await block, and it basically reads like imperative code, like away, then catch. That should make sense. Okay. As for data binding is not that difficult, neither in React or Angular. I think this is somewhat self-explanatory, apart from Angular. I'm sorry, Angular, I love you. Svelte data binding is, we talked about interpolating data into attributes, which is just the curly brackets, but this only flows downwards, which means that if you have a value in your script, you could say value equals curly bracket name, but it wouldn't go the other way. So you can use the bind directive here, and data will flow both down and up. It's reminiscent of the old AngularJS days where magic would happen and data would flow bidirectionally. Okay, and then you have state management. I decided not to go into examples with React and Angular because there are so many ways of managing state in Angular and React for that matter. When it comes to Svelte, they have one mechanism built in, which are called stores are reactive. They come in 3 variants, which are writables, readables, and derived stores. And if we just look at the example I created here, we create a store called name, that's a writable store. We're able to subscribe to the store, get a value, but then return something we can unsubscribe from whenever your component is destroyed. That's verbose. And don't worry, Svelte realized that's very verbose. So instead, you can look at the example down here and just say, just give me the store or create a name store. And then let me just do all of this stuff automatically by adding a $sign to the beginning of the store. That way it will subscribe to the store for you, and it will unsubscribe when the component is destroyed. Again, magic using the compiler. And if you look at the contract, it looks like this. You have a store, you're able to subscribe, you have a set method. If you look at the subscribe method, you'll give it a subscription and you'll get an unsubscribe hook. And to me, it looks familiar. This is the story of it. If it looks like a duck and walks like a duck, and quacks like a duck, it's probably a duck. So what I'm trying to say here is, is that the interface of the store is very similar to RxJS. So you can basically just say, get any RxJS constructs you have and plug them in, and they'll work. This is all great, and this has been very fast. If you think that Svelte is cool, please go and follow that tutorial. It's interactive, it's run in a REPL in the browser, learn.svelte.dev. And if you want to go even further after that, then have a look at SvelteKit. So SvelteKit is similar to other meta frameworks like Analog, Next.js, Nuxt, that just lets you create applications and provides you some really nice features like server-side rendering, static site generations, hydration of components, a lot of cool stuff. It's convention-based and just makes you much more productive. Have a look at that. Okay, I made it 6 minutes over time. And your minutes, yes. Okay, good. 5 minutes over time. Any questions? Yes.
Looking at this, it seems like there's a lot of non-standard syntax. What do you think about that? Durability and how do you learn Svelte?
So I get your point, but I have to correct you. The syntax is still JS. They're just using the syntax. The semantics behind the syntax is different. And it's a little bit confusing, but so my point of view or looking at it is that it's just writing something that a compiler handles for you. So yes, you have to know how stuff behaves, and you just rely on the fact that the compiler will fix stuff for you. So yes, you learn JavaScript and you abuse constructs, but I think the payoff is that you have to do much less work. So I think it works out. Some people might not like it, but I happen to like magic. Yes. So this is probably something I should have said. Everything I taught you, forget about that because the new version of Svelte is coming out. And that's a lie. That's a lie. No, don't worry about it. So Svelte realized that their framework has problems. All frameworks have problems, but they decided to handle it. So they're coming out with something that handles details about timing, which this reactive $: statement is all about, is that if you want to do something, it will update at the very last end before impacting the DOM of the browser. So instead, they added something called rules, which are they're reminiscent of React hooks, but they are again accelerated by a compiler. And they are an addition to what you have in Svelte right now. And the guy who invented Svelte and was working on Rich Harris has said that, yes, it's coming out, rules are coming out, but they will support the old standard for at least 2 major versions. Because you know that you can't just throw away all the code bases written in Svelte at the moment. Yes.
You had an example where you did the two-way binding with the bind colon value.
Yes.
Maybe could you just find that slide?
Maybe.
I'm just wondering regarding the value that you bind, because if let's export it.
Data mining. Here we go.
Yes. So if you said export let name.
Yes.
Would that that name proxy, even whatever component that was using this,
Yes.
would that also be updated?
Honestly, I don't know because I haven't done that. I think they'll just be asking for trouble.
Is that where you would use the store instead?
Yeah, you probably would. So if you have something where data is shared between components and they're gested in between, you would probably add it into store instead, and you would still have data mediated reactively. So again, yes, there are places where you have to make sure you don't do really silly stuff, because honestly, I don't know how it behaves. I haven't done that yet because I could only see problems arising from it. Further questions? Anything else? No? Okay. Thank you for your time.